So, imagine for a second that you've just been handed the keys to, like, the most brilliant, sophisticated artificial intelligence ever created.
Right, the ultimate supercomputer.
Exactly. I mean, this AI can process information in milliseconds. It maps these incredibly complex dynamic environments perfectly. It can even predict the future state of a chaotic system before it happens.
That was pretty ideal.
It does. But there is this massive, almost, tragic catch.
Okay.
Its only way of actually interacting with the physical world, its only output, is by swinging a sledgehammer.
Oh, wow.
Yeah. So no matter how elegant or nuanced its internal thoughts are, its external output is just a blunt, predetermined mechanical smash.
Which is, I mean, that's exactly the defining structural bottleneck of modern engineering right now.
It really is.
We've managed to create this incredibly dynamic, fluid, highly adaptive intelligence, but we've basically trapped it inside fixed, rigid execution.
Yeah.
It's like the brain is operating in the 21st century, but the hands are, still stuck in the 19th.
And that is exactly where our physical technology sits today, across, like, almost every major industry you can think of. But in this deep dive, we are going to show you how we are finally giving that AI a physical voice.
A way to actually interact fluidly.
Right. We're exploring how we give machines a way to interact directly with the fabric of reality itself. So, to do this, we are unpacking a stack of dense public technical disclosures.
Very dense.
Super dense. They include a 2026 publication, plus these translated conceptual notes that detail an international patent architecture by the inventor, Aleksandr Krimanov.
And just a quick note on that for everyone listening.
Yes, good point.
The materials really stress the importance of the creator's name, so we want to make sure we get the pronunciation right throughout this deep dive.
Right. It's Aleksandr Krimanov.
Aleksandr Krimanov.
Fire.
Exactly. And getting the context right here is essential because these disclosures, they aren't pitching like a new type of sensor.
Or a sharper drill bit.
Right, or a more efficient hydraulic pump. I mean, they aren't even pitching a new piece of AI mining software.
So what are they pitching?
The documents describe a completely new functional organization of physical causality.
Physical causality, that sounds huge.
It is. It's categorized as a level 3.0 physical paradigm, and the formal name for it is Intellectually Defined Processing of Materials, or I-DPM.
I-DPM.
Yeah, and grasping this leap from mechanical brute force to I-DPM is totally the key to understanding why everything from, space mining to human brain-computer interfaces is on the verge of being fundamentally reshaped.
Okay, so to really appreciate what level 3.0 means, I feel like we need to take a hard look at where we are right now because the source documents make a pretty devastating critique of modern tech.
You really do.
They break our industrial history down into these levels of physical interaction. So level 1.0 is mechanically predetermined action.
The absolute basics.
Yeah, you turn a machine on and it does exactly what its physical geometry dictates. A drill rotates. A pump transfers liquid. A crusher crushes.
Right. The function is entirely locked by the shape of the metal.
Exactly. The physical interface between the machine and the material environment is completely static.
And even if you attach like a timer or a basic computer to tell it when to turn on, the action itself is blind.
Completely blind.
Like when a steel drill bit hits rock, it doesn't know if it's hitting granite or sand. It just spins until it breaks the material, or, the material breaks it.
Which brings us to level 2.0. And this is where I think the vast majority of our cutting-edge, quote-unquote, high-tech industry sits today.
Oh, absolutely.
Level 2.0 is the adaptive control of a fixed actuator.
You see this everywhere, from advanced manufacturing to modern robotics. So in level 2.0, you have sensors measuring the environment.
Like cameras or lasers.
Right. And you have feedback loops measuring errors. You might even have a really sophisticated digital twin.
Which is like a virtual simulation, right?
Yeah, a simulation predicting the results of the machine's actions. But the controller is still just adjusting the command sent to a predetermined mechanical executor.
Okay, so give me an example of that.
So the digital twin might analyze a vibration sensor and say, okay, the rock is getting harder. Slow the drill down by 20% to avoid overheating the bit.
Got it.
So the intelligence is undeniably high, but the executor remains functionally predetermined. It's still just a drill.
So the environment is basically just a passive obstacle. The machine is essentially just reporting back on how successfully it's performing an action that was already decided before the machine was even turned on.
That is the crucial limitation right there.
Yeah.
The machine cannot change the fundamental nature of its interaction. It can only, push harder, spin faster, or stop.
See, hold on. I'm struggling to see how this is genuinely a level 3 revolution because, like, my smart thermostat measures the room, realizes it's cold, and changes its output, right?
Mm-hmm.
It adapts perfectly to its environment. So isn't this whole I-DPM thing just a really fast, highly engineered thermostat?
It's an intuitive comparison, and the translated conceptual notes actually address this exact confusion.
Oh, really?
Yeah, people often mistake highly polished existing components for a new architecture. Your smart thermostat is the epitome of level 2.0.
Okay.
It senses the environment, yes, but its physical interaction is totally locked. It can only do one thing, tell a pre-existing heating coil or an HVAC unit to turn on or off.
Oh, I see.
It cannot change the physical nature of the heat itself. It can't instantly morph into, like, an acoustic levitator because it sensed a different material in the room.
Right.
It cannot synthesize a completely new shape of a thermal gradient, targeting just one specific square inch of your couch while leaving the air around it completely untouched.
So the thermostat is still just the brain giving a command to a sledgehammer. It's just a very well-timed sledgehammer.
Precisely. Let's look at the analogy used in the source materials themselves. Think about the smartphone.
Okay.
Separately, before the smartphone, we already had processors, memory chips, cameras, LCD screens, and radio transmitters. Like, the individual components existed.
Sure, we had digital cameras and early cell phones. I remember those.
Right. But just because you dump a screen, a lithium battery, and a camera lens onto a table, it doesn't mean you have a smartphone.
No, it just means you have a pile of parts.
Exactly. The smartphone is the architecture that unites them into a radically new functional organization.
Ah.
So similarly, before Aleksandr Krimanov's architecture, we had ground-penetrating radar. We had magnetic separators. We had phased arrays and advanced digital twins. But they were separate installations used at different times.
So I-DPM isn't just a pile of known technologies.
No, it's a new architectural building where the sensing, the modeling, the synthesis of a field, the physical action, and the verification all happen in one continuous, causally closed loop.
Wow.
The novelty is not in the bricks. The novelty is in the architecture of the building.
So in level 3.0, the system defines not just a command to an executor, but the actual spatiotemporal configuration of the physical interaction itself?
Exactly. It's synthesizing a physical field on the fly.
That might be a magnetic field, an acoustic wave, maybe a localized force landscape, or a plasma profile.
Right. And the environment goes from being a passive obstacle to a causally mandatory node in the loop.
Meaning,
without the environment's current real-time response, the machine physically cannot determine what to do next.
man, that is a huge shift. So to understand how a machine can actually achieve that, we have to dive into the mathematical and physical core of how this architecture makes decisions.
We do. And the sources define this as the Krimanov Principle, or the K-Principle.
The K-Principle.
Yeah, this is the causal foundation of the entire paradigm.
The definition of the K-Principle is dense in the text, but it's incredibly elegant. It states that a previous physical action returns as a measurable response from the material environment, updates the model of its current state, and becomes the basis for synthesizing the next physical interaction.
It creates a totally new causality of physical process.
And the sources provide a formula for this causal chain. It's Rn arrow Mn arrow Wn arrow Rn plus 1.
Right.
Let's unpack the mechanics of that because this really is the DNA of level 3.0.
Okay, so the chain begins with Rn. This is the registered physical or multi-physical response.
The pushback from reality.
Exactly. And this is not a basic binary on-off signal or a simple temperature read. Depending on the environment, Rn could be the complex electrical impedance of a piece of raw ore.
Okay.
It could be the phase shift of an acoustic wave bouncing off a biological cell or the specific acoustic profile of a flowing liquid. It is the immediate, rich, multi-dimensional pushback from reality.
So if Rn is the environment pushing back like the acoustic bounce of a rock, then Mn, the next variable, has to be the system's brain processing that bounce.
Yes, the documents call it the current state model.
And they're very careful to distinguish this from what most people call a digital twin, right? Because in a lot of industrial settings today, a digital twin is just like a fancy 3D dashboard for a human operator sitting in a control room.
That's spot on. In the I-DPM architecture, the model is an operational link. It is not for a human.
It's machine to machine.
Completely. It converts that complex physical response, the Rn, directly into a control vector. Mn is a dynamic map, a state tensor, or a feature vector that mathematically represents the exact physical state of the material right at that fraction of a second.
So it's basically asking, what are the exact physical properties of the matter in front of me right now?
At this very instant, yes.
And that real-time mathematical map gives birth to WN, the synthesized spatiotemporal configuration of the physical interaction.
Which is a mouthful.
It is, but essentially the system isn't just deciding turn on, it is calculating the exact topology of a field.
Right. It determines the spatial distribution of the energy, the frequency, the phase, the amplitude, the polarity.
It decides the precise shape of a force gradient, or a local physical trap designed specifically for the material state that was just modeled in MN.
And then the execution of that custom synthesized WN physical action against the material inevitably changes the material.
Because you acted on it.
Exactly. It alters its state, which creates our final variable, Rn plus 1.
The new response.
The new response of the now changed environment, which instantly starts the whole loop over again. And the disclosures refer to this continuous causal thread as the Ariadne loop.
Named after the thread in Greek mythology that leads you through the labyrinth.
It's a perfect metaphor.
Yeah, it really is.
The Ariadne loop dictates that the system targets a specific material anomaly, probes it, acts on it, and closes the loop through that exact same causally connected area over time.
Which is so different from how we do things now, like current mining or manufacturing might scan a field with a drone, build a massive map, and then send a tractor out an hour later to blindly dig based on that old map.
And by the time the tractor arrives, the soil moisture has changed, the temperature is different, the reality has shifted.
The data is stale.
Completely stale, but the Ariadne loop is a continuous, unbroken thread of probe, act, verify, probe, act, verify on a single, localized, real-time target.
Wow, but to actually execute a loop like that, you need hardware that can physically morph its output instantly?
Yes, you do.
You absolutely cannot do this with gears, hydraulics, and levers. I mean, a mechanical arm takes time to move.
Right, physical math has inertia.
So the hardware described in the disclosures to execute this is called the Krimanov CyberActuator, and it operates as a reconfigurable field executor.
And it's important to clarify here that CyberActuator isn't a brand name for a single robot.
Okay, what is it?
It's an entirely new class of physical actuators. Let's look at the electromagnetic branch as an example. The hardware might be a single physical structure, like a linear stator.
Now, usually a stator is the stationary part of a rotary system, right? Like the outer ring of an electric motor.
Yes, but in this architecture, that single piece of hardware does something revolutionary.
Because it's shape-shifting at the level of physics.
Exactly. By pulsing electricity through different coils at microsecond intervals, that one single structure acts as the diagnostic source, sending out an electromagnetic probe.
Okay.
Then it instantly reconfigures its internal circuitry to become the sensor, catching the RM response bouncing back from the material.
Wait, the exact same physical piece of metal?
The exact same one. Then it processes the MN model and reconfigures its windings again to become the physical executor.
Oh, wow.
Perhaps synthesizing a massive traveling magnetic wave to physically push a conductive particle almost like a microscopic maglev train.
That is insane.
And finally, it reconfigures one more time to act as the verifier, ensuring the target actually moved, which is the Rn plus 1.
So it does all of this using the exact same physical structure, just by changing how it shapes fields.
Precisely.
Wait, if it's acting as a sensor, a modeler, and an executor all in the same space, the timing has to be incredibly tight. Like, how fast does this loop actually have to run to maintain that causal thread?
That brings us to one of the most critical technical refinements in the entire architecture. It's called the sub-relaxation mode.
Sub-relaxation mode.
Yeah, and the engineering notes are absolutely strict about this. They state that the cycle time of the Ariadne loop must be less than 0.1 of the relaxation time.
Okay, so the formula is basically cycle time is less than or equal to 0.1 times relaxation time.
Yes, exactly.
So let's break down relaxation time for anyone whose physics is a little rusty. Relaxation time is basically how long it takes a physical system to return to a state of equilibrium after it's been disturbed.
The classic example is striking a bell.
Right.
The relaxation time is roughly how long it takes for the ringing to fade, the vibrations to dampen, and the metal to become completely still again.
Okay, makes sense.
So what the sub-relaxation mode dictates is that the entire cycle of probe, model, synthesize, and act must complete its next action before the environment's transient response from the previous action decays.
Oh, so it's acting inside the window of physics.
Exactly.
Like if you hit the bell and you wait for the bell to stop ringing before you take your next measurement and decide your next strike, you've lost the causal connection to that specific state of energy. The system has basically reset.
Right, you're starting over. But the machine must synthesize the next action while the material is still in that transient reactive state.
That is so fast.
It is. By forcing the cycle time to operate at less than 10% of the relaxation time, the system is always ahead of the material's attempt to settle. It never lets the material return to a passive state.
It's maintaining a continuous, real-time physical conversation with the molecular or atomic structure of the target.
Yes.
You know, this is where the whole concept really locks into place for me. It's like watching a master jazz musician.
Oh, I like that analogy.
Think about it. A level 1.0 machine is a player piano. It just mechanically hits the keys on a predetermined paper scroll. It doesn't care if anyone is in the room.
Right.
A level 2.0 machine is a very talented musician reading sheet music. They might play a little louder or softer depending on the conductor, but the notes are locked. The outcome is predetermined.
Yep, they can't change the song.
But this I-DPM architecture, it's a jazz musician who doesn't just read music. They actually listen to the acoustic bounce of the room. They feel the audience's heartbeat. And in a fraction of a second, they change the very shape and tuning of their instrument before playing the next note to perfectly match the physics of the room.
The output is causally linked to the environment's immediate response. The instrument itself adapts to the reality it encounters.
Exactly. So we have this blueprint for a machine that can talk to matter through fields rather than physical destruction. What is the very first thing we should do with it?
Well, the sources point directly to one of the most urgent, environmentally devastating, and physically inefficient industries on Earth.
Global mining.
Global mining. The disclosures refer to the state of the 2026 extraction industry as a literal catastrophe.
And the geopolitical and environmental data back that up entirely, don't they?
Oh, absolutely. Over the last 50 years, our global consumption of natural resources had exploded.
Yeah, I was looking at this United Nations Environment Program report, the UNBP. They published a global resources outlook in 2024 that is just staggering.
It's grim reading.
It really is. It showed that the extraction and processing of natural resources generate more than 60% of the emissions causing global warming.
60%. And if we do not fundamentally change our architectural approach, by 2060, the volume of resource extraction could grow by another 60%.
And the core problem isn't just that human beings are using more stuff. The fundamental physical problem is how we get that stuff.
The old model of mining is basically a paradigm of mass destruction.
To get a few grams of gold or like a few kilograms of lithium for an electric car battery, we have to destroy, transport, and chemically boil tons and tons of surrounding rock.
The terminology used by Aleksandr Krimanov's documents is stark. They state that the old paradigm manages the ballast, not the target.
The ballast being the waste dirt.
Right. We literally blow up a mountain. We load the rubble into massive autonomous dump trucks the size of houses. We crush it in giant digital crushers, and then we run it all through toxic chemical baths.
And even if you put a level 2.0 AI on it and use autonomous robotic drills, a robotic drill is still just a drill.
Exactly. The industry is functionally blind between the exploration phase and the extraction phase. We're destroying thousands of tons of non-target mass, the ballast, just to sift out the valuable fraction at the very end of a massive logistical chain.
This creates a terrifying paradox when we talk about the green energy transition. I mean, the sources cite the International Energy Agency's Global Critical Minerals Outlook for 2025. Demand for lithium grew by almost 30% in 2024 alone.
And that's just lithium.
Right. Demand for copper, nickel, cobalt, graphite, rare earth elements, it's skyrocketing because we need these materials to build wind turbines, solar panels, and electric vehicles.
Which means green energy, if it continues to rely on level 1.0 and 2.0 mining methods, is going to massively increase this destructive physical footprint.
The environmental burden is simply being transferred from the tailpipe of a gas-powered car directly into giant open-pit mines and toxic tailings storage facilities.
The old paradigm has reached its architectural limit. You cannot mine your way to a clean environment using mass destruction.
And this is exactly where DEMETER K enters the picture.
Yes.
DEMETER K is the industrial expression of this level 3.0 architecture. It stands for the new industrial paradigm of intelligent resource harvesting. We are shifting from extracting mass to targeted harvesting.
And the phrase resource harvesting is chosen very deliberately to contrast with Mining.
Because mining implies blowing stuff up.
Right. Mining inherently implies the destruction and extraction of mass. Harvesting implies the detection and selective collection of a target directly from the environment while leaving the surrounding environment intact.
It's the difference between selectively picking an apple off a branch versus bulldozing the entire orchard, hauling all the wood, leaves, and dirt to a processing plant, and chemically dissolving the pulp just to extract the apple seeds.
That is exactly it. And how it actually achieves this is detailed in a specialized branch of the architecture called I-DPM, which stands for Intellectually Defined Processing of Conductive Materials.
Okay, this is where we see that CyberActuator stator in action on a macroscopic scale.
Yes. Picture this. Imagine a linear stator hovering over a mineral flow on a conveyor belt, or even hovering over a seabed.
Okay, I see it.
It starts by sending out a high-frequency electromagnetic probe. That probe hits the material, and the RN response bounces back.
So it's listening to the echo.
Right. The system registers the complex impedance and phase features of whatever it just hit. Because a particle of gold or copper or cobalt has a very specific, unique physical signature, the MN model recognizes it instantly.
It spots the apple in the orchard.
Exactly. And then, acting entirely within that sub-relaxation time window we discussed before the material's energy state settles, the system synthesizes a completely custom spatial field.
It morphs.
It reconfigures its windings to create a directed, traveling magnetic force field that physically reaches out and grabs just that conductive particle.
Wow.
It moves the particle into a receiver, verifies it's gone with Rn+1, and leaves all the surrounding silica, dirt, and water exactly where it was. It never lifts the main mass of the environment.
So it's pulling metal out of the dirt using invisible magnetic fingers.
That's a great way to visualize it. And to quantify the success of this, the expert notes introduce a new metric for industrial efficiency.
Right, because in the old industry, success was measured by throughput, like tons of rock moved per hour, or the sheer volume of the crater left behind.
But DEMETER K introduces the selectivity coefficient.
So the formula for the selectivity coefficient is denoted as the Greek letter eta subscript selective. It is calculated as the mass of the target substance divided by the total mass involved, so the mass of the target plus the mass of the ballast environment.
Eta selective equals M target over M target plus M ballast.
The ultimate goal of this new industry is to drive that M ballast number to an absolute minimum. You don't want a ratio of 10,000 tons of dirt to 1 ton of gold. You want almost zero dirt.
And this aligns perfectly with the European conceptual framework of Industry 5.0.
Oh, Industry 5.0.
Yeah. Industry 4.0 was all about automation, putting digital controllers on level 1.0 machines to make the blind, destructive processes autonomous.
Just making the dumb machines run by themselves.
Right. Industry 5.0 is supposed to be about sustainability, human centricity, and respect for planetary boundaries. But the source text makes this brilliant, cutting observation.
Which is?
Without changing the actual physical execution layer, Industry 5.0 is just a humanized digital sticker slapped onto the destructive physical processes of Industry 4.0.
Ouch. But true.
You were just feeling better about the mountain you were blowing up.
So the CyberActuator is the actual physical execution level of Industry 5.0. It fundamentally changes the unit of production from volume of destruction to accuracy of the result.
And this brings us to a monumental shift in global economics. If we can extract a target without moving the environment around it, if we eliminate the ballast, it suddenly unlocks critical resources that were previously completely impossible or, financially ruinous to access.
Which opens up environments we previously thought were untouchable.
Exactly.
Let's start right here on Earth with tailings, because this is a massive, immediate problem. Tailings are the toxic waste dumps left behind by old mining operations, right? They are essentially giant artificial lakes or mountains of crushed rock and chemical sludge.
There are huge environmental liabilities. Dam failures at tailings storage facilities are catastrophic. But ironically, because the old level 1.0 and 2.0 mining methods were so inefficient, these dumps are full of residual critical metals.
Wait, really?
Oh yeah. There is leftover lithium, cobalt, rare earths, even substantial amounts of gold and copper just sitting in these dumps.
But the traditional approach to remining them is terrible. To get those residual metals, a mining company has to dig up the entire toxic dump all over again, homogenize the whole mass, transport it, and run it through even more chemical baths.
It's incredibly expensive, it uses vast amounts of energy, and it stirs up all the toxins.
DEMETER K completely changes the formulation here. Instead of treating the dump as a homogeneous mass that must be physically moved, a swarm of CyberActuators can be deployed.
A swarm.
Yeah, they map the residual components spatially using the K-principle to probe the sludge and selectively harvest the specific metals from local concentration zones using field-directed extraction.
It extracts the critical raw materials while simultaneously performing ecological remediation. You clean the dump while harvesting from it.
It's an incredible solution for terrestrial waste, but it gets even wilder when we look at the ocean, subsea and under ice resources.
Yes, the deep ocean.
We know there are massive placers of gold, heavy minerals, polymetallic nodules, and cobalt manganese crusts sitting on the ocean floor. The sources detail how river systems over geological time have transported and sorted these heavy minerals into hydrodynamic traps.
Like modern deltas, buried paleochannels, coastal barriers.
Right.
And the disclosures actually provide a parametric equation for assessing these basin resources.
Oh, I saw that.
It states that the mass of gold equals the mass of transported sediment times the source fraction times the average gold content times the concentration trap efficiency times the preservation degree.
Okay, that's a lot of math.
It is, but the point of including this math isn't just to prove there's a lot of gold in the ocean. It is to demonstrate that these are highly concentrated, geologically stable systems that have naturally sorted the materials over millions of years.
But right now, to get to them, you have to completely ruin the ocean floor. The mechanical paradigm requires deep-sea dredging. You have to drop massive grinding machines to the seabed, destroy ancient aquatic habitats, lift thousands of tons of muddy, sandy pulp through miles of pipe to a giant surface ship, process it with chemicals on board, and then dump the waste plume back into the water, which basically chokes marine life for miles.
It's ecologically devastating.
But with the I-DPM architecture, you don't need a massive dredging factory. You deploy a compact, intelligent field executor.
Right. It goes down to the seabed, locally loosens the sediment, forms a limited contained flow, and probes it.
And then it uses that traveling magnetic field again.
Exactly. It identifies the conductive minerals, uses the field to harvest just the target metals, and instantly returns the depleted sand right back to the environment it came from.
The seabed structure remains almost entirely undisturbed. The main mass of the environment, the ballast, never has to be lifted to the surface.
And the geopolitical implications of this are massive. The 2026 documents specifically address Europe's critical mineral crisis.
Oh yeah, this is a huge deal. Europe relies heavily on imported processed minerals.
Very heavily. By 2035, China could control up to 80% of processed rare earth elements and battery graphite.
And the tension is clear. Europe desperately needs these materials for defense, artificial intelligence, aerospace, and the green energy transition.
But politically and environmentally, they cannot afford to open massive, ecologically disastrous open-pit mines across the European continent. The public simply won't stand for it.
No, there would be riots.
So DEMETER K offers a way out. It allows Europe to access its own low-grade ores, historical tailings, and coastal resources without the ecological conflict of mass excavation.
But I have to ask the scale question here because visualizing this is tricky. Can one little CyberActuator hovering over the sand really replace a massive, miles-wide open-pit mining operation?
Which is a fair question.
Because it sounds incredibly slow. How do you meet global demand by plucking one grain of metal at a time?
Well, that is where the concept of the swarm comes into play. The Level 3.0 architecture doesn't rely on scaling up one giant machine until it's the size of a skyscraper.
Oh, okay.
It utilizes a distributed industrial environment of nodes working in a mesh network. The documents call an individual module a micro KOK, GOK being an industry term for a mining and processing plant.
So it's a microplant.
Yes. Imagine thousands of these microplants. A swarm of these modules continuously shares energy, refines their collective physical models, distributes work zones, and acts as a virtual decentralized factory.
Oh, that makes sense. So they're all talking to each other.
Constantly. If one node encounters a particularly dense rock formation, it instantly updates the MN tensor for that rock type and shares it with the entire swarm.
So they all learn instantly.
Right. And if one node fails, the swarm seamlessly redistributes the tasks. You achieve massive industrial scale through distributed, intelligent networking rather than physical gigantism.
And if you want the ultimate proof of why we need this shift from physical gigantism to field-based physics, we have to look up.
Ah, yes. Space mining.
The ultimate frontier of the old paradigm. And frankly, the place where level 1.0 and 2.0 machines look the most ridiculous.
Space exposes the absolute absurdity of trying to use mechanical mass extraction. Think about how an earth mining machine actually works. It relies entirely on its immense weight, the gravity of Earth pulling it down, stable support and friction to press a mechanical drill bit or a steel bucket into solid rock.
You need a heavy machine to push hard into the dirt.
Now take that exact same machine to microgravity, like on the surface of an asteroid or the moon.
Right.
You still have mass, but you have virtually no weight. Every mechanical action, every single time you try to push a spinning drill into rock out. Newton's third law dictates there is an equal and opposite reaction pushing the machine away from the rock.
So in zero-G, drilling is an absolute nightmare. The harder you push the drill, the faster you push your multi-billion-dollar robot back into outer space.
Exactly. To counteract that using old physics, you require incredibly complex anchoring systems. You have to bring artificial mass. You need momentum compensation wheels. You need incredible dust protection because without gravity to settle it, the abrasive dust just floats everywhere and destroys gears.
It sounds like a total nightmare.
It is. The old paradigm is literally trying to launch an Earth mine into space. It's fighting the physics of the environment rather than using them.
But with the space CyberActuator acting as a micro-GOK on an asteroid, the disclosures specifically point to asteroid 16 Psyche as a prime example, right?
Yes, Psyche.
Psyche is over 200 kilometers wide and is believed to be potentially up to 60% metal by volume. A swarm of CyberActuators on Psyche wouldn't use massive gravity-dependent crushers.
Not at all. They hover over the regolith. They probe it, build a dynamic model of the composition in real time, and use field traps and magnetic gradients to separate the metal from the silicate right there on the surface.
They use physics, not mechanics, to pull the resources apart. No massive anchors required, no heavy crushers.
It's mind-blowing because it completely bypasses the physical limitations of gravity. It turns the lack of gravity into an advantage.
It's the ultimate validation of the K-principle.
It really is.
Okay, let's take a deep breath because we need to make a massive conceptual pivot here.
We do.
If this architecture, this K-principle of Rn, Mn, arrow, W or N arrow, Rn plus 1, if it can perfectly map a chaotic environment in milliseconds and delicately sort microscopic metals out of asteroid dust or deep-sea mud using perfectly timed real-time feedback loops,
Yes.
could we apply that exact same causal loop to the most complex, delicate, and chaotic electrical environment known to science?
We are talking about the living human nervous system.
Exactly. We are moving from rocks to biology. The disclosures outline the transition to Neurointerface 3.0 in vivo.
This is where the true universality of the Aleksandr Krimanov architecture shines.
It really is.
The foundational patent architecture outlines how interacting with biological tissue is fundamentally no different than interacting with conductive ore, provided you manage the fields correctly.
Let's look at current neurotech, the level 1.0 and 2.0 stuff. Even our most advanced brain-computer interfaces today usually involve a surgeon sticking fixed metallic electrodes directly into the brain or placing a grid of them on the skull.
Very invasive.
Yeah. Then the system blasts predetermined pulses of electricity into the tissue, or it just passively listens to the brain's signals.
A level 2.0 neurointerface might detect a biomarker like a specific tremor signature in a Parkinson's patient and use that feedback to adjust the timing or the amplitude of a stimulation pulse. That's adaptive control.
Right.
But the physical geometry of that pulse, the actual channel the electricity travels through the tissue, is completely fixed by where the surgeon physically placed the electrode.
But the brain isn't a static bowl of jelly.
Far from it. The human nervous system, the surrounding glial tissues, the blood vessels, the cerebrospinal fluid, it is a constantly changing, highly dynamic material environment.
It's a lot.
Exactly. Throughout the day, tissues swell, fluids move, local temperatures fluctuate, and electrical impedance changes constantly. Sticking a fixed electrode in there is like trying to use a fixed drill bit in shifting sand.
So in Neurointerface 3.0, we treat the biological tissue and the skull itself not as an obstacle, but as a constantly changing physical path.
We apply the K-principle in vivo. The system doesn't just fire a blind pulse of electricity. It sends a targeted, microscopic diagnostic probe.
Okay.
It registers the complex neurophysiological and multiphysical response. That RN response could be electrical impedance, a phase shift, an acoustic bounce, or even a microthermal gradient.
And that response forms an individual, real-time, current state model, MN, of the brain tissue at that exact millisecond.
And then, based on that model, it synthesizes a unique field configuration.
Just like it did with the gold particles.
Exactly. It calculates exactly how to shape the electromagnetic or acoustic field to perfectly bypass a phase barrier or to focus energy deep into the tissue without scattering. It synthesizes the WN field, fires, measures the actual neural response, the RN+1, and reconfigures the entire field topology for the next pulse.
To put this in perspective, think about a heart pacemaker. An old level 1.0 pacemaker just ticks on a mechanical timer.
Tick, tick, tick.
Right. A slightly better level 2.0 one speeds up when its accelerometer senses you are exercising. But an I-DPM pacemaker wouldn't just tick. It would map the electrical resistance of your heart muscle, millisecond by millisecond.
Right.
It would reshape the physical topology of its electrical pulse to perfectly match your unique physiology in real time, maneuvering around scar tissue dynamically. It's a fluid conversation with the body.
We are moving from blasting the nervous system with a wide beam flashlight, hoping we hit the right spot and don't cause too much damage, to having a highly specific, bidirectional, fluent conversation with individual neural pathways.
And when you are having a conversation with the brain, safety is paramount. You can't afford to have the system make a mistake.
No, the stakes are incredibly high.
The documents outline a protocol for this called dynamic neurohomeostasis.
This is a critical distinction from how medical devices currently operate. In older systems, safety is an afterthought. It's a hard limit. It's like a fuse that blows if the machine gets too hot.
Right. It waits for a problem to happen.
Exactly. In I-DPM, safety is a dynamically updated variable inherently built into the MN model.
Oh, that's smart.
The system is constantly monitoring parameters like local specific heating, charge balance, mechanical pressure, or any signs of anomalous neural synchronization that might indicate a seizure.
If the model predicts that the next field pulse might cause cellular stress or heat the tissue even a fraction of a degree above the safe limit,
the system restricts the WN power instantly. It changes the phase, rebuilds the spatial profile, deactivates certain sections, or immediately terminates the cycle.
that is incredible.
And crucially, it acts before the damage occurs, because it is calculating the physical outcome of the interaction in real time within that sub-relaxation physics window. It never pushes the tissue out of equilibrium.
And how does this physical interface actually attach to a person? Because we aren't talking about jacking a USB cable into the back of your head.
No, thankfully not.
The documents describe something called an intelligent field skin.
The intelligent field skin is the ultimate biological application of the CyberActuator. It can be a flexible, wearable matrix resting on the skin, or an ultra-thin implanted mesh.
Okay, so like a patch.
Yes. It consists of multiple controlled sensor execution cells. What's amazing is that an individual cell in the skin can instantly swap its function, just like the stator we discussed earlier.
Right.
1 millisecond, it's acting as a sensor, reading a faint neural signal. The next millisecond, it acts as a transmitter.
And the millisecond after that, it can act as a shielding layer. This is the part that is truly incredible to me. To understand how a flat mesh on your skin can target something deep inside the brain without cutting you open, think about dropping pebbles into a calm pond.
Okay, a pond.
If you drop one pebble, you get a ripple that spreads out evenly. But if you drop a dozen pebbles in a perfect circle at the exact right microsecond, the ripples will interact.
They'll bounce off each other.
Right. They will cancel each other out in some places, and they will all meet perfectly in the center to create one giant, concentrated splash. The rest of the water remains mostly calm.
Constructive interference.
Yes. The field skin does this with electromagnetic waves. It uses constructive interference to target a deep neural pathway or a tumor, while the surface skin and surrounding tissue feel almost nothing.
It creates a temporary, entirely non-invasive window into the brain without a single surgical incision. It's a distributed physical interface that constantly defines its own method of interaction based on the geometry of the body it's attached to.
So whether we are harvesting gold particles on the ocean floor, plucking metals from an asteroid, or dynamically guiding electrical signals in a living human brain, the architecture scales seamlessly across vastly different environments.
Because the underlying physics of causality remain exactly the same.
Rn, arrow, Mn, arrow, Wn, arrow, Rn+1.
The physical response dictates the mathematical model. The model dictates the physical synthesis changes reality, and reality provides a new response. It is a universal language for manipulating matter.
This has been a massive journey. We've gone from the level 1.0 mechanical brute force of the Industrial Revolution, dumb machines digging dumb holes, to level 3.0, the I-DPM architecture.
It's a complete paradigm shift.
We've unpacked the K-Principle equation and the Ariadne loop. We've seen how DEMETER K shifts us from destroying the Earth to intelligent resource harvesting, selectively picking the target and leaving the environment untouched.
And solving the ballast problem.
Yes. We've explored how a swarm of micro-GeoK cyber-actuators could mine asteroid Psyche without ever needing an anchor, solving the zero-gravity problem. And we've seen how this exact same causal loop creates a safe, bidirectional conversation with the human nervous system through an intelligent field skin.
It is a profound transition. The intelligence of our digital systems has finally been given a physical execution layer that matches its complexity. We are no longer trapping a supercomputer inside a sledgehammer.
So, how does knowing this change the way you look at the machines around you? Tomorrow, when you drive past a construction site and see a massive excavator tearing into the earth, or you look at highly automated robotic factory line, you will now see them for what they really are, mechanically deaf and blind.
Stuck in the past.
They are locked in the past, performing predetermined motions in a chaotic, dynamic world. You are now equipped to see the future of physical AI. You know what Level 3.0 looks like.
This raises one final fascinating question, though.
Oh.
Yeah, and I want to leave you with an unaddressed concept from the margins of these disclosures to mull over.
I love these. Let's hear it.
We've talked extensively about how a swarm of cyber actuators can perfectly adapt to its environment, dynamically reshaping its physical fields to selectively target and extract resources. But what happens when we use this architecture not to take from the environment, but to build?
Oh, wow. Building instead of harvesting.
The documents briefly mention field-directed assembly. Imagine an I-DPM swarm that acts less like a mining tool and more like a synthetic biological cell.
Okay, so it's putting things together.
Exactly. Instead of identifying a mineral and pulling it out, the swarm uses those invisible, perfectly matched magnetic and acoustic fields to organically pull raw materials from the surrounding environment and precisely assemble them into a structure.
That's crazy.
Could a swarm eventually use the dirt, carbon, and minerals in the environment to grow infrastructure, molecule by molecule, the exact same way a tree grows a branch?
Like a swarm that maps a ravine, pulls the iron and carbon from the earth around it, and literally grows a bridge out of the dirt?
The capability to perfectly and dynamically dismantle reality implies the capability to perfectly and dynamically assemble it. If you can control the physical interaction at the subrelaxation level, there is no fundamental difference between taking matter apart and putting it together.
That is a staggering thought. A true mastery of physical causality. And on that mind-expanding note, we will leave you to ponder the future of physical AI and what happens when the intelligence we've built finally learns how to touch the world.